Okay, so this is the last example in 8.4. We didn't get to it yesterday, so I wanted us to do it. I'm going to let you do it by yourself, okay? And make sure you got it okay. So 6x squared plus x minus 15 over 4x squared divided by 3x squared plus 5x. Okay? So I'll give you a couple of minutes, and then we'll go over it, and then we'll move on to the next section. All right, is that what y'all got? Did y'all do that first? Okay. Now, I'm going to say when you first started factoring this year, this would have been really hard for some of y'all. So you should have been okay, right? Everybody did it? Oh, no, it's not the final answer. Okay, so now it looks like this, right? So can I cross-cancel anything? What? All right. So now, what's left on the top? And on the bottom? Yeah. Now, y'all listen, you're going to have to be really careful about stuff like this, okay? You're going to have, because if you're not careful, you'll lose this X right here just because your writing's messy or, you know, something like that. So when you look back to see what's left, you be sure and look carefully. Don't just glance over there and slap something on the paper, all right, because it'll be wrong. All right, anybody got a question about multiplying and dividing fractions? Rational expressions. Okay? All right, so let's do today. Today, we're only going to do 8.5a. 8.5 has two parts. One part is adding and subtracting rational expressions, which is what we're going to do. And then tomorrow we'll do the other part. Complex, what does that mean? Hard, difficult, oh my word, please help me, okay? Fraction. It's going to be a fraction over a fraction with a bunch of mess in it. So add and subtract, rational, what does rational mean? Yeah, it's a fraction. Expression, very good. Okay, so let's talk about this first. In order to add and subtract rational expressions, what must you have?
Common denominator.
Very good. You must have a common denominator. All right? Now, what is that called? What is that common denominator called? A least common multiple. Okay? He's called a least common multiple. Why did I write it like that? There you go. It's called an LCM. Now, can I find an LCM on my calculator? Yes, you can. I taught you how to do it, but I'm going to show you one more time. It's a freebie because, guys, you can't use it on these problems, okay? But it's always nice to know little calculator tricks and things. All right, so where am I going to find LCM on my calculator? Yeah, y'all, the catalog is the easiest way. It probably is somewhere else. If I went to math and pressed around in the buttons or something, it'd probably take y'all 5 minutes. It'd take me 25 minutes. But, I mean, why am I going to do that when I can just go second and catalog? It's in the alpha mode, so I'll choose the L's, and then I see it right there. Okay? And what do you want to find the least common multiple of? Let's just show you how it works. 47, and then you have to press a comma. Now what's the other number? 91. Oh, that's a good one, Spencer. 47 and 91. There it is, 4,277. The typical way, and the way you did it when you were in the 6th grade, is you took the biggest number and you started listing its multiples. 91 times 1 is 91. 47 go into it? No, not evenly. 91 times 2 is 182. Does 47 go into it? No. See what I'm saying? That's the way you would do it. So the calculator is very fast. All right. Everybody okay? All right. Okay. So now let's work some problems. Okay? Here is example 1A. We're not going to have a bunch of A's. We're going to have an A and a B and a C. Oh, I see what you're saying. No, this is the last and only A in the examples, okay? The second A, I guess you would say. So 7 over 4x plus 3 over 4x. Can you work this problem?
Yes.
Yes?
Mm-hmm.
Okay. What do you say? 10 over 4x. Good answer?
No.
Why? You can reduce it. You can simplify it. What can I reduce it by? 2 goes into here 5 times, and 2 goes into here 2 times. So my answer is actually 5 over 2x. Everybody agree with that? Okay. Now, so let's look back at this 10 over 4x for a second. What's going to be the common? Y'all, it's always nice to know where do people most likely mess this thing up. All right? What's going to be the common mistake? What are they going to get? 10 over 8x, okay? You get a test, you get a little bit anxious, you get a tad bit stressed, and you're going add, so you just add, all right? And you get 10 over 8x, and then you missed it. You got it wrong, okay? So be careful and learn how to perform under pressure. Because everything that you do that's really, really important in life is going to have a little pressure on you, okay? So if you want to practice and be good at it, I think sports are always a good way, all right? I think about if someone was throwing me the football and everybody in the stands is screaming at me and all my teammates are screaming at me and I'm going to catch it and everybody on the other team is chasing me, trying to kill me, that would probably be kind of stressful, okay? So that's practicing on it, okay? When you play those kind of things, then you practice, and the more you practice, the better you get. It is a skill. All right, here's the next one. 2x over x plus 6 minus 5 over x plus 6. Okay, so this is a subtraction problem. Guys, we're going to fix our subtraction problems every time. What do I mean by that? What are we going to do? Yeah, we're going to change it to an addition problem. And how can I do that? What do I have to do? Yeah, you just pull that negative sign up to the top. Now, what if there were more than one term in the top? Very good. You would have to change the sign of everybody on the top. We're going to work a problem like that, see if you remember it. Okay? Now, you'll put it on the bottom too? Why? That's exactly right. Then you put a negative over a negative, and now you've just made it a positive. Okay, so you cancel the negative sign out. You didn't take care of it. All right, so here we go. What's on the top?
2x.
Yeah, just 2x minus 5. And what's on the bottom? X plus 6. Can I cancel these x's out? Very good. That's my answer, guys. Okay? Look at this last one. I'll let you do this one all by yourself. Okay? So 2x squared over x squared plus 1 plus 2 over x squared plus 1. All right? I'll give you a minute. Okay, y'all got it? What y'all get for the answer? It's 2. It is 2. Okay? Because look what you get. On the top you get 2x squared plus 2, and on the bottom you get x squared plus 1. But what do I see about that top? What can I do up here? I can take a 2 out, so I'm just going to do it right up here. And the reason I'm going to do it up here, because if it's helpful to me, if I can reduce it because I factored it, then I will factor it and reduce it. But if I can't, then I'll just go back and circle this answer. Okay? When you take a 2 out, what are you left with? There you go. Now, does that reduce? Yes. These are gone. Okay? And all I'm left with is that 2 on the top. All right. Anybody got a question? Okay. So, let's talk about something else. What if I were going to add two fractions and they didn't have a common denominator? All right? For instance, what if I was going to add 1/2? No, let's not do that. Yeah, let's do 1/3 and 1/12. Okay, I want to look at it a little bit differently, okay? And the reason is because I want to show you that what we're fixing to do right now because it's going to be different, it's not just numbers. It's going to be polynomials, binomials, things like that, okay? So it's going to look a little bit differently, but I want to show you that we're doing the same thing that you used to do with numbers. Now, if you were in Algebra 1, your algebra teacher might tell you to do the prime factorization of these numbers. Okay? Well, this one's just 1 times 3, and the 1 doesn't really affect anything, does he? This one is 2 times 2 times 3. Okay? Now, in your brain, 2 times 2 is 4, and 4 times 3 is 12. In your brain, you just said, hey, what's the smallest number that 12 and 3 both divide into evenly? That's how you find the least common denominator, right? That's what your brain said, and you said, oh, it's 12. Okay? But I want to show you that what we're fixing to do is really the same thing that you're doing. Okay? Here, there's only 2 rules. There's only 2 rules. The first rule is, I'm going to write them down in just a minute, but I'm not going to write them down right now. The first rule is every factor must be represented. And the second rule is you must take the most that any one has. Okay? So every factor has to be represented. I don't have to write this 1, do I? Because he doesn't change anything. All right? Do I need to write the 3? Yeah, because I said every factor has to be represented. So 3 times. Do I need to write this 2? Yes. And how many 2's do they have? 2. So remember the second rule? I must take the most that any one term has. So how many 2's do I have to take? 2 of them. Do I need to write this 3? I already got him, people. I don't need him to take him. Okay? I represented him. Yep, he's down there. All right, what's 2 squared? What's 4 times 3? 12. Okay, so let me say this. If you don't get that, it's not a big deal. All right? I'm just kind of warning you that this next problem that we do, they're trying to lead you into working a problem, and these tend to be the hardest ones for kids to get. They're like going, what? What? And then we start working problems, and they're like, oh, that's why you did that. And I'm like, yeah, that's why I did that. But I'm just telling you, some of you may not get this, but it'll be okay. All right? So I want you to find the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. Okay, so let's think about this. Remember yesterday when I said, what were those 3 words that I wrote at the top of our paper, really big? Factor, factor, factor. So what we need to do is we need to factor everything. The denominators of our rational expressions, we're going to make sure that they're all fully factored. Okay? So let's look at this thing. Now, what's the first thing that you see? Okay, that's what a lot of people see. But what should be the first thing that you see? You can take something out. Okay? Now, if you didn't take it out and you factored it, you would see it. It would be 2x plus 4 and 2x minus 4, and then you'd be like, what? 2's and 4's? I should have taken a 2 out. And then when you take a 2 out of both of them, you're really taking a 4 out. Okay? I'll show you that on this one over here. All right, so let's look right here. Let's take our 4 out first like I want to. Okay? And then you're left with what? X squared minus 4. Now, how does that factor? Okay, x plus 2 and x minus 2. All right, now let's look at this one over here. Okay, let's take out a 6. When you take out a 6, what are you left with? Okay, and then what does that factor into? X minus 2 and x minus 2. Oh, it's a perfect square trinomial, isn't it? Okay? So some of you won't see it till you do this. And then you go, oh, Craig, that's a perfect square trinomial. All right. So what would have happened if you had looked at this and you were just being methodical? Okay? You're just like, I got to factor that thing right now. I got to factor him. Okay? And then you went, oh, that's 2x and 3x. That makes 6x squared. A plus sign means they'll both be what this one is, minus and minus. I got to make a 24, and I need to make a 24 here. So let's see, 6 and 4. That's 12, and 12 will make my 24. Okay, so if I put a 6 here and a 4 here, I'll make 12 and 12, and they will add to be that 24. And then I look at this, and what do I see right here?
You can pull out 2.
Craig, I should have taken a 2 out. And what am I left with?
X minus 2.
And what do I see right here? I should have taken a 3 out. And what am I left with? And what do 2 times 3 give you? 6 times x minus 2 times x minus 2. Do you see what I'm saying? So even if you worked really hard and you did this, you're still okay. But I don't want you to do that and then not be like punched in the face with the fact that both of these have common factors within them. Okay? When I see something like this, it should jump out to you people. When you see it, you should say, what? A 2 and a 4? Oh, I should have taken a 2 out. You see what I'm saying? Okay, so you don't have to start all over again. You can just work with what you got just to end up with the same thing. All right, so let's go over here and let's write down what the 2 rules that I said. The first rule is every factor must be represented. That means that if I've got something written down there and it's multiplied by something, he better be somewhere down there in my least common multiple, which is a least common denominator. Okay? All right, here's the next thing. You must take the most that any one has. Yeah, and that means like any fraction, any denominator, okay? And you'll see that in just a minute. All right? So, what is my least common multiple? Well, let's look at the numbers first. We're just going to do it a piece at a time, okay? Between 4 and 6, what's the least common multiple between 4 and 6? Yeah, and that's the common mistake. And the reason is because I said least common multiple. That makes you think what divides into them, what can you reduce it by? Y'all, that's not what I'm asking about. If I had said, what's the least common denominator between 4 and 6, would you have said 2? Oh, Lord, help me. All right, so here's what you need to think about. What's the smallest number that 4 and 6 will divide into? 12. That's the least common multiple, people. Okay? Let me say this. You must take the most that anyone has. People, can I make this 6 smaller? No. All I can do is make things bigger. So can I make it into a 2? No, you can't. So 2 can't possibly be the answer. All right? It just can't. So you need to, when you look at numbers, you need to think, hey, what's the smallest number both of those things will divide into evenly? All right? So that's 12. Now, do I have an x plus 2 down here? Do I have an x plus 2 down here?
Not yet.
Not yet. So what do we need to do? Put 1 down there. X plus 2. Because look what it says. Every factor must be represented. So, where's my 4 and my 6? They're in that 12. I got an x plus 2. Do I have an x minus 2?
Not yet.
Not yet, but I'm fixing to. I'm going to write it down. Okay? I got a 6. He's in the 12. Do I have an x minus 2? He has 2 of them. Must take the most that any one has. This one has 2. This one has 1. Which one do you have to take? 2.
Okay. So
Okay?
basically you're taking apart the factors from each one.
That's exactly right. We're writing them all down. And the big guy chooses how many you get. Okay?
Now the purple confused me.
This up here?
Yeah.
It was just because this morning some of the kids factored it without taking the 6 out. And then they go, oh, I factored that thing without taking the 6 out. And I said, well, look, it still works. But please tell me when you see a 2x minus 4 that your brain's going, whoa, wait, 2x minus 4, I could have taken a 2 out. You see what I'm saying? I just want you to recognize things like that. You should. Okay? All right, now let's try a problem. Here we go. Example 2. Y'all, I'm doing 3 examples, and that's it. Okay? And it'll take us 15 minutes. So, here we go. 7 over... Actually, I'm just doing this one and one more. 9x squared plus x over 3x squared plus 3x. Okay, you ready? What's the first thing you should do? factor those denominators. Guys, you cannot find a common denominator until all the denominators are fully factored. You can't factor 9x squared, okay? I mean, you could write it as 9 times x, but that's crazy. We get that. All right? Can I factor this denominator? What can I do? Take out a 3x. And what are you left with? X plus 1. Remember yesterday I turned that thing around and a bunch of y'all left that 1 off. So be careful about that, okay? So now I'm going to cross this denominator out because visually I don't want to be looking at that mess anymore. This is my new denominator. Okay, so let's go underneath it, draw us a line. We're going to write our common denominator right here. Okay? Between 3 and 9, what's the least common denominator?
9.
Very good. Okay? Sometimes it's just the way I said it. All right? If you say it, what's the least common multiple, a lot of kids want to say 3. It's not, but I don't know. It's just the way your brain thinks. But when I say least common denominator, most of the kids will get. That's what it is. It's the greatest common factor, actually, which is what we take out. Okay? All right. Between x squared and x,
X squared.
why?
Because you have to take the greatest of
You have to take the most that anyone has. So x squared. Y'all listen to me. Here's why. Can I make that x squared into an x? No. See how you can just make things bigger? You can't take things and make it smaller. Okay? Shh. No. You can't. All right. Now, I've taken care of my 9 and my x squared. What about my 3? He's in my 9. What about my x?
inside the X.
He's in the x squared. What about the x plus 1? Got to write him down. X plus 1. So this is my least common denominator. Do you see how it's easier when you're looking at a problem than it was when I just said, what's the least common multiple? Okay? Now, what do I have to do to this denominator to make it look like this? What's missing, people? That's all I'm asking. So I multiply the bottom by x plus 1. Well, now what else do I have to do? Why is that?
Because what you do to the bottom, you gotta use to the top.
Why?
Because it's
Otherwise it would mess up.
yeah, it would change the
Why?
multiplication algebra.
Because
It would be
if you have
different.
like, if you have 1/3 and you multiply the bottom by 1/3 and then by a 3rd, but you don't multiply the top, that's
Because
the
the
same.
rules doesn't matter.
Okay, one
That's and see, that's what I want you to say, Spencer, because that's the whole point. Is that you guys know the rule, but you haven't thought about why is that rule. Nobody said, hey, why who made that rule up? Well, we got that rule for. Listen to me. Listen to this.
That's for the universe.
What's the only thing that you can multiply a number by and not change it? 1. What's x plus 1 over x plus 1? 1. That's why, people. Because it's not because the rule says whatever you multiply the bottom by, you multiply the top by. Okay? Because I'm just trying to write this in a different way. Okay? Now, what property are we using here? Distributive. What's 7 times x? What's 7 times 1? Okay? Everybody okay so far? Now, what do I have to do to this denominator to make it look like this? What's missing?
X squared plus
By 3x. I need a 3 to make a 9, and I only have one x, so I need another x. So that means you got to multiply the top by 3x. What's 3x times x?
9x squared, or 3x squared.
Okay, so plus 3x squared. All right, now let's see what this... Y'all, don't leave stuff like that. That just looks so unprofessional. All right, put that thing in standard form. What goes first? Perfect. What goes next? Very good. All over. Okay, now we don't want to be multiplying this mess out, okay? I know you know how to do that. I've already tested you on it, okay? But there's another reason. Because I'm going to always try and factor the top and see if I can reduce it. So really what I do is I just kind of go up here on the top and I go, wonder if I could factor that. If I can factor it and it helps me reduce it, then I will. If I can factor it and it doesn't help me, then I'll circle this answer right here. Okay? I'm not going to factor it because I might have messed up. All right? So 3x times x plus sign means they'll both do what this one is. Whoa, is this thing going to factor? No, he doesn't factor. So this is my answer. All right, everybody okay? Okay, let's try the last one. This is example 4. Example 4 looks like this. Now what we're going to do is we're just going to do it a little piece at a time. All right? So x plus 2 over 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. Okay, I'm going to give you 30 seconds, and I want you to do the very first thing that you should do right now. You have 36 seconds. You got it? Okay, what did you do? Very good. You made this a plus sign, and you changed everybody's signs up here. Okay? Now listen to me. I'm telling you, if you don't do that kind of stuff, guys, I know that you're going to put that negative on that negative 2 and make him positive, but I know, too, that at least once out of all those problems, you're going to forget to pull it through the whole top, all right? And it's going to mess you up, especially if I have to do something else out here with it. All right, so now what are we supposed to do? Factor. Factor the denominators. All right, so you factor the denominators really quick. All right, what'd you do right here, guys? Took out a 2. What are you left with? Okay, so now I'm going to cross that out because that's not my denominator anymore. This is. So you can't take anything out over here. Factors into x and x. A plus sign means they'll both do what this one is. Minus and minus. Factors of 3, that add to be 4. 1 and 3. 3 and 1. All right. Now, I'm going to give you 30 seconds. You write your least common denominator down. You got it? Okay. What did you write down?
2x minus 1
Very good. So, 2 times x minus 1 times x minus 3. All right. Now, watch what I'm going to do, okay? Because I'm going to show you a little trick that I use because y'all listen to me. Part of the problem, that the reason kids miss things is because their paper gets so messy, they can't even tell what they're doing. All right? So I'm going to show you a trick that I use. So, what do I do to this denominator to make it look like this? Okay, I'm not going to put it on the bottom. Okay? I'm not going to put it on the bottom. Because am I going to multiply any of that stuff together? No. Here it is down here. It's what's given me this right here. I'm just going to put it on the top. Now, when I put it on the top, what do I need to do to that x plus 2? Yeah, you're going to need to put it in parentheses because, y'all, you're not using the distributive property, all right? You're multiplying that x minus 3 times the x plus 2. So, yes, you have to FOIL it. So, let's FOIL it real quick. So, first comes first, and what do you get? X squared. The outers, negative 3x. Notice, am I doing this in my head? No, people, I'm writing it down right here because I know when I do things in my head, I make careless mistakes.
And especially when I'm multiplying and adding and subtracting. You see what I'm saying? When I'm multiplying and adding and subtracting, my brain might say 5 or 6 when the answer is really 5. You see what I'm saying? Okay, the inners give you a positive 2x. What does that make? Negative x. And last times last makes negative 6. Okay? Now what is this guy missing? That's this guy? A 2. So I'll put parentheses around this and distribute the 2. And what will you get? Positive 4x and plus 2. So now I'm going to collect all my like terms and put it in the proper order. I got 1x squared. What's a minus x and a plus 4x? Positive 3x. What's a negative 6 and a positive 2? All over 2 times x minus 1 times x minus 3. Nikki, you got a question, babe? Because I looked at this denominator and I said, hey, what's this denominator missing that this denominator has? What would I have to do to him to make him look just like this? Well, he's missing an x minus 3. So I multiply the bottom and the top by x minus 3. The bottom I'm not doing anything, so I didn't write it. It just makes my paper look junky. So this guy's missing a 2, so I put it on the top. Okay? All right, now what am I going to do, guys? I'm going to factor the top. All right? Does it factor? Yes, it does. X and x. A minus sign means a plus and a minus. What are the factors of 4 that subtract to be 3? 4 and 1. I want a positive 3, so I'm going to put my 4 by the plus and my 1 here. Does it help me any? Why? The x minus 1's cancel. So that means if I didn't do that, would my answer be correct? No, it wouldn't, guys. It'd be just like writing 2/4 on your paper. Okay? So those cancel. What am I left with on the top? X plus 4. What am I left with on the bottom? 2 times x minus 3. Don't multiply that mess out, okay? You listen to me. If you have 20 problems and I got 70 papers, how many papers am I grading? How many problems am I grading? 1,400. You're doing 20. I'm grading 1,400. If you multiply a mess like this out, I'll check it. And if it's wrong, I'm gonna mark it wrong, okay? But once I start doing that on your paper, what does it make me do to your paper? It makes me really look at it. I'm looking for everything. I'm not just quickly grading those papers, okay? As soon as you start making my life hard, it'll cost you, okay? So don't be multiplying that mess out. I know you know how to multiply that mess, okay? All right. So you want some practice problems?
Yes.
Okay, they're on the back of that sheet that I gave you yesterday. All right, you got a whole bunch of them. So practice those problems. Yes? Oh, thank you so much.